So today we're going to cover Chapter 12, Section 1. We're going to talk about sample spaces and what probability is. So first we're going to come up with some definitions here. And the probability experiment is just an action or a trial that is going to have different results. The outcome is actually the result of doing the experiment. So for example, if you flip a coin, that would be, the outcomes from that would either be a head or a tail. If you rolled a number cube, now whenever you see them referencing a number cube or a die or a dice, they're talking about a regular six-sided die with 6 numbers on it, 1, 2, 3, 4, 5, and 6. Those are the outcomes when you roll a number cube or roll a die. An event is going to be an outcome or a collection of outcomes. So for example, rolling that die or that number cube, if I said, what is the even numbers when you roll the dice? And then those outcomes or events would be a 2, 4, and a 6. The sample space is going to be the set of all possible outcomes. So for example, with the coin, we know we have 2 outcomes, and we can either get heads or tails when we flip the coin. When we roll the die, and again, a lot of times they're going to just refer to the die as a number cube. If they say a 10-sided number cube, then that would be different than a die. But if they just refer to a number cube, they're talking about a dice, and those outcomes would be the numbers 1, 2, 3, 4, 5, and 6. This would be the sample space for a number cube or a die. Next, we're going to learn how to figure out what all the outcomes are when we have a particular event. All right, let's try the next one. So let's do some examples. Now, whenever we want to just figure out how many outcomes there are in the sample space, what you're going to do is look at everything that's happening in the trial or in the event, and then you're going to multiply the number of outcomes by each other. So for example, when I flip 2 coins, there are, for each coin flip, coin number 1, coin number 2, there will be 2 outcomes. I can get heads and tails on coin number 1, or I can get head and tail on coin number 2. I take the number of outcomes and I would multiply them. So when I'm going to list my possible outcomes, I should end up with 4 of them. Now, possibly in middle school, they probably taught you a technique where they made you draw tree diagrams. And I'll show you what I mean by this. This will help you organize your data to get a nice organized list of possible outcomes. So when I flip coin number 1, I know that my outcomes on that are either it'll either land on a head or it's gonna land on a tail. When I flip coin number 2, I can get the same outcomes. However, when I flipped coin 1, I already got a head, so then I can also get a head again or a tail. And then same thing branching from the tail, I can get a head or a tail. So now to make my combinations here, I'm going to follow up the branches. So I start with the head, and then I go to the head, and then that outcome, and I'm going to abbreviate head with an H. So my first outcome could be a head and a head. So the first coin gets a head, the second coin gets a head. Or I could have flipped it and got the head, and then I could have gotten a tail for my second coin. So a head with a tail. Then I could have done the tail first, and then I got a head second. So tail, head. And then I could have also gotten a tail and then another tail. These are my 4 outcomes listed in my sample space. So again, I used H to represent head, so I didn't have to keep writing the word head, and T for tail. For the next one, we're going to flip a coin and roll a number cube. And again, this number cube is just my die. So here, if you wanted to just come up with the number of outcomes, remember the coin has 2 outcomes and the number cube has 6. So you'll do 2 times 6. And in my list of outcomes, I should end up with 12 of them. And again, if you do a tree diagram, if you flip the coin first, know that your options here are head. I'll represent that with an H, or I could get a tail. Then when I roll the number cube, remember there are 6 options on that number cube, and you can get a 1, a 2, a 3, a 4, a 5, or a 6. So if you follow the branch up, you have a head first, then the 1. So we would have a head on the coin and rolling a number 1. Or we could have flipped a head and rolled a 2. Or flipped a head and a 3, 4, 5, and 6. So all these branches are leading to our list of outcomes. Notice there's 6 of them when I rolled a head, and then I matched it with each one of the numbers on my number cube. Then I'm going to repeat the same process for flipping a tail first. So a tail with a 1, 2, 3, 4, 5, and 6. So tail 1, tail 2, 3, 4, 5, and 6. 6 outcomes here. Add them together. I have a total of 12 outcomes, which I can confirm when I did the multiplication at the beginning. So when you're answering these probability questions, you're going to probably have to write out the sample space, because what's going to happen is they'll give you a question and they're going to say, what is the probability of flipping a head and the number cube rolling on a 5? So after you list out your sample space, you're going to see that there's only one option where you had a head and the number 5. So then the probability is going to end up being 1 over 12. But we're going to see this coming up. So again, the probability of event is the likelihood or the chance that the event will occur. When the probability is 0, then you know that the event is impossible to happen. If the probability of the event is 1 or 100%, then you know for sure it's happening. Probability is going to be a number between 0 and 1. And you can represent your probability as either a fraction, decimal, or a percent. When they ask you questions, the notation they're going to use is they're going to put a capital P, and then in the parentheses will be the event that is taking place, or the event that you want to see happen. So for example, if I said, what is the probability when you flip your coin that it will land on heads? So this is how the question might be asked. This is saying, what is the probability of the coin landing on heads? And we're going to see coming up that you will say how many heads are on the coin over the total outcomes. This is what's going to be coming up next. Now, again, probability will be represented as either a fraction, decimal, or percent. Most of the questions in the homework are either going to ask you to write your answer as a fraction or a percent. Many of the percent questions will tell you to round to the nearest whole percent, so no decimals. But read the question, everything's going to be different. So here, 0 is 0%, and you know it's not going to happen. 0.25 as a fraction, that would be 1/4 or 25%. 0.5, notice it's equally likely to occur or not occur. That would be 50-50, so 50% or 1/2. And then 0.75 is going to be 75% or 3/4. And then the 1 would be 100% or 1/1. And that's a sure thing. Now, just to review how to convert fractions to decimals and then to percents, just let me review it with you. You will be using calculators because we are also covering geometric probability, and you're going to need your pi button. So if I were to convert, let's say, let me just take 3/4. If I asked you to convert 3/4 to a decimal, you take the fraction and you divide it. You put the numerator in the division box, and then you're going to divide. 4 will go into 37 times. Do the division, bring down another 0, and it goes in 5 times, and that would give me the decimal. To convert it to a percent, if you already have the decimal, you just take the decimal point, move it 2 times to the right, and it becomes 75%. What we're doing here is a percent is always out of 100. We're just multiplying it by 100. Another way, if you're going to skip the decimal part, you can also set up a proportion to convert the fraction right into a percent. And then there's moving no decimal point. Again, you should have covered all of this probably back in 5th grade. Again, if you've been using calculators, this process may not be familiar, but just make sure you know how to do simple calculations like these. All right, so let's move on. And let's see the definition of theoretical probability. We're going to be talking about theoretical probability, geometric probability, and experimental probability. Theoretical probability can be found when all outcomes are equally likely to occur. Like flipping the coin. You should assume or think that flipping a coin and it landing on heads would have the same ability to land on a tail. So they're both equally likely to occur whether the coin lands on heads or tails. So the theoretical probability is going to be the number of favorable outcomes over the number of total outcomes. So like I showed you before, when flipping the coin, if you wanted to know what is the probability of the coin landing on a tail, my favorable outcome would be the tail, and there's only one of those, over the 2 total outcomes, head or tail. And that's how you would write the probability of a tail, written as a fraction, written as a decimal, you would divide it, and written as a percent, multiply that decimal by 100, or just move the decimal point 2 times to the right. Let's say it were the number cube. So for the number cube, or the die, let's say they said, what is the probability of the number cube or the dice landing on the number 2? Well, the total number of outcomes when you roll a dice is 6. And out of that list of outcomes, there is only one number 2. So that probability would be 1/6. If they ask you to represent it as a decimal, you would divide 1 by 6. And this ends up being 0.16 repeating. And as a percent, it would be, you would move it 2 times. So like if you wrote this, would be 16 2/3%. They're not going to probably show you something like this with the 0.6 repeating. If you realize that 2/3 is 6 repeating, that's how you'll usually see the percent. However, most of the homework questions are going to expect you to round that to the nearest whole percent. So that answer would have been 17. Now, let's say back to the number cube still. Let's say instead they said, what's the probability of that dice landing on an even number? Well, if you look at your list of outcomes, 1, 2, 3, 4, 5, and 6, you can see that there are 1, 2, 3 even numbers. That's my favorable over the total, and then simplify. And again, 1/2, 50%, or 0.5. Let's try some more examples. Now, this is using the same sample space that we did back at the beginning, tossing the coin and rolling the number cube. Remember, your outcomes were a head with a 1, 2, 3, 4, 5, and 6. And then the same thing, tossing the tail and putting it with a 1, 2, 3, 4, 5, and 6. Now, you're going to have to write out the sample space in order to answer the questions. So here it says, what is the probability that the coin shows a head and the number 5? So again, I'm going to look at my sample space and I'm going to see that there is only one outcome that has the head and the 5. So that would be my favorable. I only have one of them out of the total, which is 12. If they ask you to represent it as a decimal, you would divide it, 0.083 repeating. And then as a percent, this would be 8 1/3%. Next one. This time, they've given us the results. So we're going to just use the information in the table. So here, they want us to find the probability of a student choosing a t-shirt with a gold emblem. Remember, we need to find the total number of t-shirts and we need to find the total number of gold t-shirts. So I'm going to add up my columns. The number of gold emblem t-shirts is 10 plus 6, and it's 16. The number of silver emblem t-shirts is 8 plus 6, it's 14. Giving me a total of 30 t-shirts. So I have a possible 30 t-shirts. Some of the gold emblem t-shirts are green, some are red, and then the same thing with the silver. So my total is 30, and my total of my favorable, which are the gold, is 16. I now need to always reduce the fractions. This will simplify to 8/15. So if they just ask you to represent it as a fraction, that would be the answer. If they ask for a decimal, we'll divide this. It turns into 0.53 repeating. So as a percent, it would be 53 1/3%. Now to just show you how I'm getting that 1/3 instead of the 3 with the bar over it, if you take this and solve this as a proportion and you cross multiply 15 times x, 15 times 100, 8 times 100, divided by 15, so 800 divided by 15, 15 will go into 80 5 times, subtract, bring down, 15 will go into 50 3 times, and notice now I'm not going to add a decimal, I write it as a mixed number. So this would go on top of the 15, so it becomes 53 and 5/15, and then I reduce the 5/15, and that's how it becomes the 1/3. So that's how I get it as a mixed number if it's repeating. So the probability of a complement of an event is, and this is written as probability of A bar or the complement of A. Remember, a probability is a number between 0 and 1. So to find the complement of an event, you just subtract the event's probability from 1. If it's given to you as a percent, you'll subtract it from 100. So here it wants us to find the complement of the probability of event A. Well, if event A was given to me as 0.45, its complement would be 1.00 minus 0.45, and it would be 0.55. So that would be the complement of event A when event A's probability is 0.45 or 45%. Now, classic example, if you talk about the weather, let's say the weatherman says today there is a 30% chance of rain. The complement of that would be not raining, and that would be 70%. Just subtract 100 minus the 30. So the two events together, the event and its complement, need to add to either 100% if it's presented as a percent, or add to 1 if it's given as a decimal or even a fraction. Next, we're going to talk about geometric probability. So for the geometric probability, we're going to be using our area formulas. So what we can do is either have to calculate the area or maybe volumes or surface area of the different shapes and then write them as like a ratio. So here, it's a picture of a dartboard, and it says your dart is equally likely to hit any point inside the square board. And it wants to know, are you more likely to get 10 points or 0 points? So what I need to do here is figure out the probability of my dart landing on the 10-point section, and then find the probability of the 0-point section and see which probability is greater. So let me go ahead and zoom in here. So it's those shading type questions. So again, I'm doing two different probabilities. I'm going to be doing the probability of it landing in the 10-point section. Let me go ahead and do that. And then I'm also going to do it for the 0 points. So my 10-point section is that little red or pink circle. Now notice on here, each one of these little radii are 3 inches long. So this tells me that I'm going to do the area of the red circle with a radius of 3. So remember, it's going to be the area of the smallest circle. So the area of the smallest red circle, so the smallest circle, over the entire board, because it wants it over the total. So the entire board, which is the square. So let me go ahead and, so the square, the way I can figure out how long each side is, if each one of these is worth 3, I know that this whole radius here is a 9. And then if I draw another radii in this direction, it will also be 9. So that would make each side of my dartboard 18. So I'm going to do the area of the square, 18 times 18. And then I'm going to do the area of the smallest circle. And the smallest circle has a radius of 3. So this is going to be pi r squared. And my radius is 3. So 9 pi. Next, let me go ahead and simplify this. I could actually reduce 9 over 324. I can divide both of these by 9, and it'll simplify to pi over 36. I'm going to go ahead and divide this because I need to compare it. And this is why we'll be using a calculator, because you're going to need your pi button. So once I divide pi by 36, I get 0.0873. Now I need to do the probability of the 0 point section and see which probability is going to be greater. Now the 0 point section is that blue area. So in order to get the area of just the blue, I'm going to do the area of the square minus the area of the largest circle. All right, so the top of the fraction is going to be the area. So, well, the blue section is, what I'm trying to find is the area outside the largest circle. And again, this is going to be over the area of the whole square. So the area outside the largest circle can be found by doing area of the square. So the 324, the 18 times 18, minus the largest circle, and that radius is 9. So 9 pi divided by the area of the square. Now, you're using calculators, so you can go ahead and just do this straight on your calculator. Now, if we weren't using calculators, we could reduce this and divide all these by 9 and change these to, let's see what I can change these to. This should be 9 squared, so this should be 81 pi. I'm going to divide all these by 81, and these all become 4s, and this becomes a 1. So 4 minus pi over 4. And if I go ahead and simplify this, 4 minus pi gives me 0.8584073464 over 4. And then I have to divide that. And my probability here is 0.2146. Now, if you didn't want to simplify this, you can do this on your calculator, minus 81 pi divided by 324. Now, this is OR. So if I go ahead and do that math, this is going to give me 69.5309951 divided by 324. And when I do that, I still get this same answer. So this is the probability of it landing in the 0 point section. And I'm comparing that to the 10 point section. So what I'm comparing are these two decimals, 0. Not do it in highlight here, 0.0873 and 0.2146. I need to see which decimal is larger. This one is the bigger decimal. So this tells me that I'm more likely to get 0 points versus 10 points because that's got the higher probability. Now, experimental probability is based on repeated trials of an experiment. And then the number of trials is going to be the number of times the experiment is performed. The success is what you're looking for when they're asking the probability question. So for example, let's talk about just flipping a coin. So my experiment could be flipping a coin. And let's say I want to do 10 flips. So this would be the number of trials, would be however many times I flip the coin. So I'm going to flip it 10 times, and I'm going to record the results. Now, if you think about this theoretically, when you flip a coin, and if you were to flip it 10 times, theoretically, you should think you should get 5 heads and 5 tails, because the theoretical probability of flipping a head is 1/2. However, when you actually flip a coin and you write down the results, it may not be 50-50. So let's just pretend that I flipped a coin 10 times, and let's say on my flip, I got 3 heads. and 7 tails. And again, you'll be given the results of an experiment and they'll write it down for you in a chart or some format. So let's say the question said, what was the probability of that coin landing on a head when you flipped it 10 times and you recorded the results? That probability would be 3 heads, that's the successes, over the 10 times you flipped it. If it would have said probability of tails, then that would have been 7 out of the 10. And again, be able to turn these into decimals and percents as well. So again, when you're doing the homework, just remember to read how they want you to enter your answers. So let's do one example and then you can start your homework. So this one, they've spun this spinner 20 times. Now, when you're doing an experiment like this, depending on the situation of maybe where the spinner is sitting, let's say the spinner was sitting on a table that was slanted or tilted. Maybe, look at the results here. The green came up 9 times. Maybe the table was tilted, and maybe it was tilted so that the spinner kept falling in that green section. So depending on different situations, when you do these experiments, it could affect your results. So this question is asking us, for which color is the experimental probability of stopping on a color the same as the theoretical? So let's go through and let's do the experimental probability for each color. Now, we could have, if they didn't tell us how many times they spun the spinner, we would have had to add 5 plus 9 plus 3 plus 3. But if you read up here, they told us they did it 20 times. So that's going to be my total. So for red, it's going to be 5 over 20. Always reduce, so it's 1/4. For the green, that's going to be 9 over 20. I don't need to simplify. For the blue, 3 over 20. And then for the yellow, 3 over 20 as well. So that will be the yellow. Now, I need to go now and calculate the theoretical probability of my spinner. Theoretically, all 4 colors have the same probability because there are 4 sections. So when I did red, so this was the experimental results. Now I'm going to do the theoretical. So for red, 4 sections, 1 of them is red. And notice, here's my answer. But I could do the same for green. There's 1 green section out of 4, 1 blue out of 4, and then the yellow, same thing. So the one where it actually was the same as the theoretical was the color red. And that is it for the notes on section 12.1. Now, little hint for your homework tonight. You're going to get 2 questions, at least 2, number 4 and number 11, where they're telling you you're rolling 2 dice. Remember, on each number cube or each dice, there's 6 outcomes. And if you roll 2 different dice, know that the first dice has 6, the second dice has 6 outcomes. 6 times 6, that produces 36 outcomes. So when you go to do number 4, you need to list all 36 outcomes. However, if you look at number 11, they gave you a picture of the 36 outcomes. So my advice to you is when you go to answer number 4, jump down to number 11, maybe screenshot that picture so you don't have to draw out all 36 outcomes. Okay? Because the outcomes on the dice are either you can roll a 1 and a 1, or a 1 with a 2, a 1 with a 3, 1 with a 4, and so on. And there's 36 different combinations. So when you're doing the homework, jump to number 11 to get that screenshot so you don't have to list all 36 outcomes.